Welcome to HouseLab Scientist. In this video, I'll be showing you how to design your own AC to DC converter and DC to AC converter, that is a full bridge rectifier and H-bridge circuit. Let's get started by making a full bridge rectifier. Now, I'm going to start by placing 4 diodes. Now, this is EasyEDA, which is a free software you can download. I'll link it in the description. It's basically a good circuit designing tool. You can also export your projects to TLC PCB to get your parts, and your actual parts is a different source, but you can get your PCBs printed. Let's start by placing ground and also placing VCC, and let's consider that this is an AC source. So once we do that, we can then proceed to designing the circuit. But let's just see what AC is. So AC is basically alternating current, which means that the current shifts from a positive vector to a negative vector 60 times every second. That creates the 60 hertz thing, and it can be found in 220 volts, 240 volts, and even 110 volts. Now let's place a capacitor, I'll tell you why we are exactly placing the capacitor. Now, after we do that, we will start by creating a mesh in the diodes. So basically connecting every diode to each other, just to create the circuit. Well, you have to do that. Okay, let's take the D1 and connect the cathode, that is the output, to the D4's cathode, that is the output, negative, or the strap that you see on the diodes. It can vary, not just a gray strap, but a red strap sometimes. Okay, now let's connect the anode of the D4 to the cathode of the D3. You can actually start making on a PCB. And let's connect the anode of the D3 to anode of the D2, and let's connect the cathode of the D2 to anode of the D1. Now you can start by soldering it slowly. I'm not showing it to you because, well, these circuits actually exist in small packages which you can buy. Then let's connect the VCC to the cathode and anode bridge of D1 and D2. Then let's start by bridging the D1 and D4 gap, that is a cathode D4 D1 gap, to ground. Okay, that's one thing that you need to take care of when you're making circuits. Okay, let's not do that. Let's just connect it to D4 D3 cathode anode gap, and let's connect the D1 D4 as the output, and the D2 D3 as the other output for the DC signal. Now that's actually the ground. So okay, I'm just going to take that off because I want something as a load. Let's take in this case a resistor as the load. So there we go, R1. Okay, let's see if we can rotate this. No, there is no rotating option. Wait, there was. Well, okay, let it be. Okay, we'll manage it. So the C1 to R1 is the positive signal. Now, why is the C there? Okay, let's just connect the ground. Okay, that's the thing done. Now, why is the C there? That is to reduce these bumps that you see. As the capacitor charges, it just nullifies those things and gets a clean cut signal. Now let's start with a H-bridge circuit. Okay, I'm going pretty fast, I know, but yeah. Okay, let's start with a N-channel MOSFET. Yeah, N-channel one. Let's place 2 N-channel MOSFETs on our playground, and let's place 2 P-channel MOSFETs on the playground. Now let's consider these are P-channel, these are not. So what is a P-channel, what is an N-channel? N-channel is basically something that can have the current flowing when there is power through the gates. A P-channel is something that won't have current flowing when there is power on the gates. So it will be off when there's power, and it will be on when on means it shorts the drain and the source. Not exactly shorts, but since there is a resistance there, it doesn't short it, but it acts as like a switch. So we'll label it as N1, N2, and P1 and P2. Yeah, N1, N2, P1, P2. So next what we are going to do is we will create source, that is we'll just create a load first, which is a resistor here again. Okay, I recommend you not to make this circuit because AC is dangerous and can kill you. Well, not at 5 volts, but yeah, at 100 volts or 200 volts, yes. So let's make a 5 volt DC source. Let's create a ground, and let's start by connecting the ground. Okay, these are the N-channel MOSFETs, and these will be on. Okay, wait, I forgot to place the NE555B, which is the timer IC. Okay, let's type 555, which is not there. Oh, it's not there? No, it's not there. Let's just type B. Okay, there we go, NE555B. Let's place it down here. Okay, I'm not creating any peripheral circuit right now. Let it just be the output, since I just want a 60 Hz signal, and that is what you basically want because of switching. So you want a 60 Hz square wave, AC square wave. So yeah, that is how it's going to be. Let's connect this 60 Hz signal to each and every gate of the MOSFET, all the MOSFETs. Okay, one thing to note, it would be recommended to use an IGBT or insulated gate bipolar junction transistor for this thing, but yeah, you can use MOSFETs also. MOSFETs are metal oxide semiconductor field effect transistors. Yeah, it's a big name. Let's just connect the ground now. So I'm going to connect the ground to one N-channel MOSFET and one P-channel MOSFET, as the ground should be on both the times. I mean, once on each side. So once on the positive side of the resistor, which is in this case the left side for a on signal, and the power goes directly to the resistor, which is basically positive, normal positive. And as you can see, from the N2 it goes to the right side of the resistor, and from the N1 the positive goes to the left side. So once it's on, once the circuit is on, we get the 60 Hz signal. There will be positive signal, positive power on the left side and negative on the right side. Now let's take the case when the circuit is off, when there's no power on the output, no power on the gates, when the 60 Hz goes to zero signal, the 60 Hz signal goes to zero, the ground will connect to P1, which should go to the left hand side of the resistor when the N channel gauge will be off. So let's do that. There we go. And we have positive power coming down, so that we have the positive going to the right side of the resistor. So there we have it. H-bridge explained. Not exactly explained, but yeah, I mean, it works. I think you get what I mean. So once it's on, it's one wave, positive wave, and once it's off, it's a negative wave, and that is what exactly it is. Actually, you can add those, add a few diodes to it, just to prevent any backlash of the current, and that's why I usually recommend IGBTs rather than simple MOSFETs. Well, that's it for now. Let's take a leave. Goodbye.